Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, and a very good morning. So, we'll continue our lecture from the previous class. So, we have covered half of the chapter 2. So, today we continue with the remaining chapter 2. So, before we start, we recite Surah Al-Fatihah. Al-Fatihah. Okay, so for today, we will continue with the examples of lighting circuits schematic wiring. So there's various type of the lighting circuits that we can design. Some of it, for example, the first one is the single light point controlled by a one-way switch. So we have a switch here. Okay, S is the switch, and then we have one light point. So when we on, the switch is on, then the light will on. And then the second is the two light points. So we have two light points controlled by one switch. So we also can control two lights with a single switch. Okay, and then we also can control two light points with a separate switch. We have switch 1 and also we have switch 2. Switch 2, we control the light 2, while switch 1, we control the light 1. Then we have the single light point. This one is one only light, and then it controls by two ways of switch. Normally we can see this circuit when we have for example two bedrooms shared with one bathroom. So we can use two switch to control one light point. Then we also have three light points. Okay, three light points controlled by two-way switch and intermediate switch. So basically, if we have um, uh, stairs and then we have three switch, the first stairs, for example here lah. Okay, we have here, and then we have that one, we have this one, and then we have one here. So for example, the drawing is not too okay, but hopefully that you can understand. So this is a stairs. So this one is we have the switch here, and then we have the light bulb here. Okay, and then we have one more switch here. So this one, for example, this is the switch 1. This one is switch 2. And then we have the switch 3 here. Okay. So this one, the first stairs. Okay, this one is the ground floor, the first floor, and the third floor. Okay. So here, if we want to control one light point, we can control by three switch, 1, 2, and 3 switch. Okay, so switch 2 is the intermediate. Okay, intermediate switch. Okay, so this is the intermediate switch. So this light point can control by 3 switches. Okay, so we continue with the other lighting circuits schematic wiring. So this one is the single fluorescent light point controlled by a one-way switch. Okay, so we have the fluorescent lamp here. Okay, so will be controlled by a single switch, one-way switch. Okay, so we have here is a switch, and then the capacitor. Okay, so basically this fluorescent lamp is a form of inductive load on AC main supply, so it will result in poor power factor. So this capacitor, okay, capacitor is purposely to correct the power factor and then bring it back close to unity. Okay, and then we have here is the choke, okay, choke or the magnetic ballast. So we have two types lah, okay, magnetic ballast and also the electronic ballast. Electronic ballast is more efficient compared to the magnetic ballast. Okay, the function of this ballast, okay, this choke or ballast is used to as a current limiter. Okay, it will control the voltage and also the current to make sure that sufficient current through the filament or the tube. So here is we call the tube or the filament, filament. Okay, so we have, for example, here is A, and then this is point B. And then also we have here is the starter. Okay, starter. Okay, so the starter is the time. This starter is the time switch allows current to flow to the filaments. Okay, so basically the the function of this fluorescent light is first of all the switch will turn on. Okay, when we turn on the switch, so the current will flow to the choke. Okay, the current will flow to the choke and go to the filament B. For example, here is filament B, and then go to the starter. And then the starter, after and then the starter will be on. Okay, so the current will flow back to the neutral. And then after 1 or 2 seconds, the starter will be open. Okay, starter will be open, and this choke will create a high voltage because we know that V equals to L di over dt. Okay, so because we know uh, when the choke creates the high voltage, okay, it will also create a high current. Okay, so this high current will trigger the electron in this tube to move from B to A, and then will light up the tube. So this is the operation of the fluorescent light. Okay, but you just know that this switch can switch on and off the fluorescent light point. Okay, next is the examples of the socket outlet schematic wiring. So the single socket outlet SSO. So this is the socket outlet, the single socket. So this is the wiring for the single socket. We have earth, neutral, and live. Okay, so we continue. For the radial connection, we connect to SSO with the main supply. Okay, so this one for the red dial. Then we have the ring circuit connection. So ring circuit connection, we have more than three, okay, many SSO that we want to connect together with the main supply. So that one we call the ring circuit connection. And then this is the final circuit for 13 amp socket outlets. So normally if you want to use the radial, the circuit type of radial, you can use for the rating for the MCB is about 30 or 32 amps. Okay, and then the sizing for the cable or conductor must be around 2.5 square millimeter, and then the maximum flow area for this ring type is about 100 square meters. For the radial, there are two types. The first one is if the maximum flow area is around 50 square millimeter, you can use for the protection rating for MCB is about 30 to 32, and then the sizing for the conductor or cable is about 4 square millimeter. And then the second type is if the flow area is about 20 square meters, then you can use the radial type with the rating of 20 amperes, and the cable sizing is about 2.5 square millimeters. The next is the minimum cross-sectional area rating for the conductor. Okay, so if you want to use for connect the wiring for the lighting and fan circuit, you have to use the cable sizing of 1.5 square millimeters, and the material is all copper lah, for the conductor. And then we have, if for the 13 amps socket outlet circuit, we can use sizing for 2.5 square millimeters. So this is the rule of thumbs for the circuit design. But actually there's a calculation on how to determine what is the sizing of the cable that can be used. Okay. And then we have the general power circuit, for example, water heater, cooker unit, motor or pump. So the sizing is around 4 to 6 square millimeters. And if we have the main circuit, we can use this one is the from after the meters, okay, from entering the distribution board, okay, the DBs, we have the main circuits, then we will use the conductors cable is around, the sizing is around 16 to 25 square millimeters. So this is the sum of electrical accessories or appliances that can be used in your house. So for example, first we have the fluorescent lamps. Okay, as I showed before, the operation of the fluorescent lamps. So these fluorescent lamps basically using the magnetic ballast, and we have to make sure that the watt loss is not exceeding 6 watts. Shall be equipped with the dry paper type of capacitor. As we know that these fluorescent lamps is an inductive load where it can result in poor power factor and also voltage drop. So this capacitor is used to correct the power factor. And then if we have the fluorescent lamp using electronic ballast, so this is more efficient, or the high frequency electronic ballast. So it is not no need to use the capacitors. And then we also have the outdoor domestic lamp installations shall use weatherproof and waterproof lamps. And then we have the submerged light installations. For instance, the swimming pool fountains shall have waterproof lamps with a voltage that not exceeding 12 volt AC. So we